Hello everyone, my name is M. Christus Gloria and I am from CSMA section. Today my topic is F1 score, the balance between precision and recall. Introduction. What are the classification problems? Classification is a type of supervised learning where the goal is to be predict categorical labels. Example, spam versus not spam and fraud versus unfraud. Example, identifying whether an email is spam or not. Why do we need evaluation matrix? Accuracy alone is not sufficient in imbalanced data sets. For example, detecting fraud when only 1% of transactions are fraudulent. We need more insightful metrics to measure model performance effectively. And understanding the precision and recall. Precision. Precision measures how many of the predicted positive cases were actually correct. It is useful when false positives are constantly costly. Example, mistaking making a email as spam. And the formula for the precision is equals to TP by TP plus FP. And here two TP represents correctly predicted positive cases and FP represents incorrectly predicted positive cases. And understanding the precision and recall. Recall. Recall measures how many of the actual positions positive cases were correctly identified by the model. It is useful when false negatives are costly. The missing example, a missing cancer diagnosis. Recall. The formula for recall is TP plus FN. Here TP means true positive, correctly predicted positive cases, and FN means actual positive cases what were missing in the model. And the trade-off between the precision and recall are explanation of how increasing one affects the other, increasing precision, decreasing recall. If we make a model more precise, we reduce false positives by only predicting positive when we are very confident. And the effect of this is fewer incorrect positive predictions are like high precision, but we might miss some actual positive cases. Then we tell it is as tell it is a low recall. For example, a spam filter with high precision will only classify as a email as spam if it is 100% sure and reduces false positives, and however it may miss many actual spam calls, and these are false negative increases. And the trade-off between precision and recall. Example with different thresholds in classification. High threshold. Example 0.9. High precision and low recall. The model only labels a transaction as fraudulent if the probability is greater than or equals to 0.9. And few false positives FP. The model is very selective in calling something fraud. And more false negatives are many actual fraud cases do not reach 0.9 probability are missed. And the effect is high precision, mostly flagged frauds and actually fraud. And low recall, many frauds are undetected. And what is the F1 score? The definition of the F1 score is a harmonic mean of precision and recall. We already know that what is precision and recall, right? And what provides a single metric to evaluate a model when both precision and recall are important. And the formula for this is F1 is equals to 2 into precision into recall by precision plus recall. And why not just use accuracy? Problems with accuracy in imbalanced data sets like Accuracy is misleading in imbalanced datasets because a model can predict only the majority class and still achieve high accuracy while ignoring the majority class. And the precision and recall in F1 are better metrics as they evaluate how well the model detects the minority class instead of just overall correctness. And the techniques are techniques like resampling and oversampling, undersampling. The threshold turns help improve model performance for handling imbalanced data effectively. Precision recall curve and F1 score. Visual representation of the precision recall curve. The precision recall curve is a graph that shows the trade off between precision and recall at different classification thresholds, and it evaluates model performance, especially on imbalanced data set where accuracy is misleading. Understanding the PR curve, in the x-axis we take recall. It means true positive rate. X-axis measures how well the model captures actually positives, and y-axis is precision, positive predictive values. And y-axis measures how many predicted positives are actually correct. And curved shape. A high performing model will have a curve that stays near the top right, and the high precision and high recall. The random model will have a near flat curve, means poor precision and recall balance. And the precision recall curve and F1 curve. How to choose a threshold for a good F1 score? Choosing the right threshold is crucial for optimizing the F1 score as it balances precision and recall. Here's how we can do it effectively. Threshold selects the impacts F1 score by balancing precision and recall. A high threshold increases high precision but lowers recall, while a lower threshold does the opposite, and it's vice versa. The optimal threshold is where F1 score is highest, ensuring the best trade off between precision and recall. And the methods to find the best threshold includes grid search, precision recall curve analysis, and uh, uh, ROC curve. And the practical approach. The practical approach, the test, the test multiple thresholds and compute F1 score at each the one that gives the highest values. And the use cases of F1 score. Applications in healthcare, fraud detection, and spam detection. Examples: healthcare, used in medical diagnosis, for example, detecting cancer or rare diseases like sugar and many other. To, to false to balance false positives, unnecessary tests, and false negatives, diagnosis. And the fraud detection helps identifying fraudulent transactions by optimizing precision, avoiding the false fraud alerts, and recall, catching the actual cases. And the spam detection ensures a balance between blocking spam mails, high recall, and avoiding misclassifying important emails as spam, high precision. And thank you.